Okay, so this is the sort of stuff you'll see often on the AP test, where instead of giving you an explicit function written out, they'll give you a picture of it, a graph of it. Here we have h of x. Some function is defined in terms of the area under a different function, and they ask you for the derivative of that initial function at a specific value. So first let's get a function for h prime, and we're going to do that by applying second FTC to this thing. We're going to differentiate an integral. In doing that, notice we are starting at a constant, so that's cool. We are simply going to keep g. We're going to lose the integral, and we're going to plug in the upper limit. H prime becomes g of, plugging in the upper limit gives us 3x. And we're going to then chain on the derivative of the upper limit, the derivative of the upper limit being simply 3. Now they want us to figure out what h prime is at a specific x value. So h prime at that specific x value, we just plug in the same x value over here. So instead of 3x, we have 3 times negative pi over 3 times 3. Simplifying this gives us g of, 3's cancel out, negative pi, then times 3. And then we can go to the graph to get the value for g of negative pi. G of negative pi. Okay, negative pi is going to be right here. I don't know exactly what that is. To figure that out, let's see here. It sure looks like it's going to be pi. We should probably verify that and not just assume. This is a linear piece of the function. Its slope, let's see, we go up 2 pi and over 2 pi. So the slope is going to be 1. And our b value is the y-intercept. That's going to be 2 pi. So plugging negative pi in for x would give us negative pi plus 2 pi. That would equal pi as kind of figured with our eyeballs. So g of negative pi is in fact pi. We're going to multiply that by 3 and get 3 pi for the answer.